Some of these things are lessons that I have learned working for large enterprise organizations. I worked for a 60,000 person company in North Dakota, government agency, I shouldn't say company, but the government agency, so you can imagine that kind of stigma. I went and tried to run my own business, and then I'm no longer running my own business, so that tells you how good of a businessman I was. And then I came and worked for Randy, and then I ditched Randy and tried to do the startup scene, and now I'm back working for Randy. So I have a little bit of experience with the startup scene was like 6 people. So I have a little bit of experience in a whole bunch of different types of environments, and I've seen enough of this kind of software, both Python, I've written Cold Fusion, I've written PHP, I've written fair bit of against a number of different types of database backends. Had some fun. I'm in the midst of multi-processing, multi-threaded environments and doing all kinds of fun stuff. And I've learned that there's some things to know soft skills wise to be a good professional software developer. There's kind of an important word there at the beginning, which is common mistakes that professional software developers make. And that's kind of important to remember, because some of these things don't really matter if you're just working on your own hobby projects, which is great. By all means, exert some of these tendencies on your own hobby stuff. But once you get into an interpersonal relationship with the people that are working around you, there's some things to know and some things to care about, especially when you're working within the context of a business environment. So I want to run through a couple of them, and I've tried to assign them some useful quips that would be memorable. And if they're not memorable, then that just shows how good I am at creating quips. And so the first one is identity crisis. This is the first one that I learned both in one sense working at level 12. In one sense, I really learned it at the startups that I've worked at. If you are walking into your software development job pretending, being, exuding the sense in which you're a software developer, there's a good sense in which you and the business are going to collide. Because likely within the scope of a software development company, or within the larger vein of some people are here from, at least normally there's people here from like Humana and stuff like that. Unfortunately, while you use software in your day job, you're not really a software developer. Really what you are is a business problem solver. You solve business problems. The business has issues and they need solutions to them, because the business's job is to do roughly 2 things: make money and reduce costs. Without level 12 making money and reducing costs, not only does this DerbyPy not exist, but I'm on the street under a bridge somewhere. Like that's kind of the nature of it. There's economics at play, and we shouldn't be scared of that as software developers. Businesses need to make money in order for us to make a paycheck. Software developers are amongst the top level of regularly career-trained individuals salary-wise. There's a reason for that. We provide a significant amount of value. And we need to recognize as software developers that our identity is not based in, at least professionally, identity personally. There's a lot of things you can talk about identity-wise. But professionally, your identity is not really that of a software developer. It's a business problem solver. And when you walk into a meeting with clients or analysts or somebody else in the business that's saying, listen, I need to figure out how many people we signed up last month. Really, that's not a very intense software development problem. You're not out building the next Raft algorithm to figure out consensus across a giant Kubernetes cluster. If you have no idea what I just said, don't worry about it. Like, in one sense, you're just trying to say, how many customers did we sign up last week? That's a business question. And the sooner that if you want to move into professional software development, the sooner that you can grapple onto the sense that you're a business problem solver, the better, because you will provide more value for your company, and I guarantee that you'll be able to go far, far, far further in your career. The next one is kind of taking it out of the business problem, right, and out of the business and onto the team. And I call this Greek God syndrome. All right, so Greek God, how many people have studied Greek mythology? Okay, perfect. So for everybody who didn't raise their hands, neither have I. So This is what I do know about Greek mythology, though. The gods were jerks. The gods were absolute jerks, all of them. Like, from Zeus, supposedly he's like the top, but there's like, I started looking into this, and there's like people before Zeus, and I don't really know enough about. Yeah, like there's people before that, and they were jerks too. So and it wasn't just like down the traditional like male side of the Greek gods. Like the women were jerks too. Like everybody that was a god in old Greek mythology was jerks. And as a software developer, if you're walking in as a jerk within the scope of a team, it's going to be really challenging to be able to walk into these problems that we're going to get to and ask for help. Because all of these problems that we're going to talk about, which is common Python problems that professional software developers make, these are based on things that I've actually found in either our code as we're working as software developers at level 12, or things I found in other people's code. You can't be a jerk and actually expect to get help with this kind of stuff. Because this is like stupid. Like some of the stuff is like, wow, you really should not make that kind of mistake. Especially the comma one at the bottom. You'll be like, oh, are you kidding me? I spent hours trying to debug commas. So in order to exist within the scope of a team, you can't be a jerk. You can't be a Greek god. You can't walk in and say, just because you did something nice, I'm going to cause your liver to be plucked out every day, and at night it's going to grow back. That's what happened to Prometheus. Like Zeus was pissed about some fire and said, you're going to have your liver plucked out every day for the rest of your life. You just can't be like Zeus. You have to be humble. You have to be able to walk in, because some of these problems are actually really complicated. We work on some pretty complicated stuff sometimes, and you have to be able to come together as a team. So the next one, so we have identity crisis. Don't be a Greek god syndrome. The next one is what I call hand-squeezed requirements. This is kind of bringing it back up to the business level. If you don't recognize that as a software developer, you need to get the strong sense of what the actual requirements are, you will fail time and time and time and time again, because there's no quicker way to build the wrong thing, right? To provide no value at all than to build the wrong thing. Like you will provide no value if they ask you to build something like a website, or better yet, a mobile app, and you hand them like what we do, like websites. If they ask for a mobile app and you give them a website, it's worthless. It doesn't matter how good the website is. If you don't fully understand the requirements that the business needs to solve their problems and validating that with the customer themselves, you'll have a lot of problems. And you really sometimes, what I have learned at least, is that those business requirements are hand squeezed. Like you have to get dirt. Has anybody ever made like meatloaf? Have you ever made meatballs? My mom makes the best meatballs. Mom, if you're watching, man, I love those meatballs. The trick is veal, by the way. You have to put veal in your meatballs. Anyway, the point is you have to get in there. You have to actually feel the meat, right? You have to actually squeeze the lemons out to make lemonade. You can't, yes?
And the point they're expressing to accomplish something shouldn't be written down whenever it is spelled out.
Yeah, absolutely. Yeah, as you're listening, writing down and transferring that, we call it in level 12 vision transfer, that transferring that from the business all the way down to the person who's going to be writing the code. First off, we try to shorten that distance as much as possible. The person who needs the thing, the person who's actually going to deliver that thing, we try and get it as close as possible, right? Another way to do that is to write things down. There's all kinds of tooling available to be able to do that. But you have to get in, you have to listen, you have to be able to respond to the needs. A great company, a great example of this is a company called Juicero. Has anybody ever heard of them? I don't know if I'm saying that right. They're a Silicon Valley company. They built a little product that was about this big. This is where the hand squeezed part comes from, right? Juicero built this product that was about this big, and you buy these little packs for $6 or $7, and they have fresh fruits and juices inside. You put the fresh package inside the container, and then you close this little door, and it squeezes the juice right out of this little plastic container. They charge $400 for this. Originally, they charged $600. They soon realized that $399 might be a better option. And then they went out of business because all you had to do was really take the packs, not buy their product at all, and roll the thing, and the juice came out fine. That is a fantastic example of how you have to align the requirements of what people actually need, a way to get juice, with a solution. And you got to make that as simple as possible. All right. You have to recognize that the requirements need to be fully understood. The next one is called rabbit on fire. Okay. So you have identity crisis, Greek god syndrome, hand squeeze requirements, rabbit on fire. Okay. Rabbit on fire is this. Have you ever seen a rabbit on fire? No. But let me tell you, they move quick. All right. There was a rabbit up in Canada who got a little bit too, I live in North Dakota. So Canada is like my next door neighbor. I live like 60 miles south of the border, right? So up in Canada, there was this contained, totally legal fire that some people were having. I think it was at a campfire. And this poor little rabbit got a little bit too close. And this poor little rabbit's fur caught on fire because rabbit's fur is actually very flammable. And this rabbit, obviously scared and in pain and freaking out, started running on fire very rapidly into a dry field and decided to start a wildfire. And that wildfire burned acres and acres and acres of land before they were able to contain it. And the problem is that when you start to do things, when you as a rabbit, a nice, precious little animal, get a little bit too close to certain types of fire, you might set something much, much larger on fire. A great example of this is cryptography. There are a ton of tools within Python in order to manage your cryptographic needs. Specifically, one of those tools is called, well, cryptography. It's a Python package which you can install with pip, as we learned how to do today. And there's a little part of that called fernet. And it's a way of encrypting blocks of data very securely. And they do all the hard stuff for you. As Python developers, and specifically professional software developers, we need to remember that there are a lot of smart people that have come before us. Re-implementing AES, the standard way of doing encryption, is not a good idea. We get a little bit too close to fire at that point, because likely that's not what the business needs in the first place. The business does not need us to re-implement AES. They need us to encrypt some piece of data. And there's probably somebody who has already written something to encrypt data. And we have to go out and we have to find it. So make sure that before you catch yourself on fire and before you set a whole bunch of things off and suddenly have a whole bunch of secrets being leaked, make sure to go out and do your research. Don't get too close to the fire until you know you absolutely have to. All right? Two more, and then we're on to some actual real code. The next one I call is Picasso Paralysis. This is the idea of abstraction. How many have ever seen a Picasso painting? Yeah, Picasso is kind of famous for a whole series of, he kind of changed over his entire life, but some of the early ones are rather disfigured humans, right? They're kind of block-shaped things. Like in some ways, I don't fully understand the notion of art, but if I did, I'm sure there's ways to understand it. As you start to develop something in a professional environment, there's likely going to be compounding requirements. So you get a base set of requirements, then you layer on top another set of requirements, then another set of requirements. Today I was on a call with one of our clients who is looking to enter into phase 3 of a project with us. We've built the first phase, and then earlier or late this past year, we built another phase, and now next quarter, we're gonna build the next phase. And there's a number of things that we're gonna have to strip out that we did before, because ultimately there's some things that we abstracted maybe just a little bit too early. We started designing way far ahead of where we needed to be. And now the business requirements have changed and our abstractions don't make sense anymore. In fact, if we were to look at them, they'd probably look like a Picasso painting. They wouldn't look like what an actual human looks like, right? And once, I mean, I guess in maybe a metaphysical sense, like Picasso actually is describing humanity, and you could go into the whole art like way of understanding art. But I don't really care about that. My client wants something that looks like a human, and a Picasso painting doesn't come close enough. And it's because we drew the lines in the wrong spot. As you start to think about abstracting software packages, as you're building your modules and you're building your packages, Click, for example, does nothing but manage CLIs. That's a good layer of abstraction to think about, right? Your package deals with command line interfaces. That's one abstraction. Then within that, there's a whole bunch of little abstractions. Maybe you'd abstract how you actually parse your inputs. Maybe there's a section that deals with the actual outputs. You know, there's all kinds of different ways that you can probably break stuff down, but you have to be really careful to actually mind the way in which you break your software up. And then the last one, everybody knows kind of the golden rule of software, or rather the golden rule in life. Can anybody say it?
The one with the gold makes
The one with the what?
the one with the gold makes the rule.
That's actually, there's some truth with that. The traditional golden rule might be, so in everything, do to others what you would have them to do to you, for this sums up the law and the prophets, right? So everything you do unto others as you would have them do unto you. Don't be a jerk. Treat other people how you would want to be treated. Okay? I think that there's a better golden rule for software developers, and it goes something like this, okay? This is for like long-standing projects. If you're a professional software developer, keep this always right in the back of your mind. This is it. Pretend the next developer is an axe murderer and knows where you live. That's the golden rule of professional software development, okay? There was some code that I left behind for level 12 to support, and I'm surprised that I didn't get killed in my sleep, because there's some real mess. So with that, that's some of the soft skills of being a professional software developer. Because sometimes we forget that there's people that come after us. That sometimes we get a little bit ahead of our britches. Sometimes we get a little bit too close to the fire. Sometimes we don't listen enough to fully understand the requirements and understand what the business needs. Sometimes we're a little bit egotistical, and we think that everybody should have their liver plucked out like Prometheus. And we're a Greek god, a little bit of a drama king. And more often than not, we think that our goal, we get so wrapped up in the technology, which is a lot of fun, at least for a lot of us. Most likely if you're here, or if you work for level 12 and have been forced here beyond your will, like, you probably actually enjoy this stuff. And it's really fun within our professional world to be able to do something that we enjoy. We have to remember that software is not the end goal, okay? So with that, let's take a quick look at, that's not what I want. That's not what I want either. I want to hit the resume share button. Let's look at some examples of common software mistakes. This first example is about sorting. All right, and it's kind of about sorting, but it's actually more about not using the tools available to you. And I recognize now I probably should have done this a little differently. I should have built up this custom object as necessary. But here's the challenge, is that when you have a whole bunch of things and you need to sort them, there are a number of tools that are available to you within Python, and you should take advantage of them. And as soon as you start, this is very similar to cryptography, right? Don't go re-implementing AES. Don't do that. Really bad idea. Not only will you get it wrong, it'll take you entirely too much time, and you could have been moving on to the next thing, like eating a delicious steak or something wonderful like that, right? You can, if you use the tools that are available to you, you can really understand stuff so much better. So let me show you some of the tools that are available to you for sorting, but also how to use sorting in a maybe a little bit better way. So we have a basic thing here called custom object, because I'm really crafty and unique in my naming. It's a basic object that takes a key and an other, again, because I have no idea how to name stuff. And I have two basic dunder methods described here, or implemented. One is called repr. That's just, how do I want this thing to show up on my console? So in one sense, this could be deleted. It's just for the sake of demonstration. But def dunder LT. Dunder LT is the less than function. It's what function gets called when we use this operator. When we use the little left caret operator. When we use that and we're trying to implement some way of sorting, when we want to use this method right here, the sorted method, on a collection of objects, this is what sorted calls. It calls less than. It says, is this object less than this object? And then if it returns true, it puts them this object and this object. If it returns false, I believe it does roughly a quick sort. So I think it does that, right? Swaps them, and then moves on to the next object. Right, until it gets all the way down the road, and then it's done. I don't actually know how sorted is implemented in the back. If you know, please, I look at Bill, he's smiling. Do you remember what's the actual sorting algorithm? Is it quicksort? Or anybody else? Yeah, it could be. I don't actually remember. The point is that it's going to call dunder LT. So you can implement, if you have a whole bunch of custom logic like I have here, the definition for whether or not this object is less than the other object, whether or not what's the order that they should be in, is based on this. Is the key less than the other key? In my case, I'm defining the key as an integer. Okay? So if I create a whole bunch of objects like this and I put them into a list and I assign them some values, 8, 9, 4, 2, 9, 6, 7, 6, and I hit this, that's the order that they come back, right? We see key is nicely ordered 4, 7, 8, 9, right? If just to show the point here, I can, is there a quick way to comment this out? Nope. I will just do it manually. If we run it like that, less than is not supported for a custom object, right? So if you don't have less than implemented for your custom objects, this will happen with sorted, right? And that's all we have to do is implement this dunder LT, and now you have an implementation for less than, and you can customize all this logic, which is actually quite a nice part about, you can do this for all of the methods. Dunder GT, dunder EQ, which is equals, NEQ, which is not equals. So you can override all of these operators. And it's actually incredibly valuable. If you use tools like we use, one of the Python packages that we use quite frequently, it's called SQL Alchemy. It allows you to connect to databases in kind of an abstract way. It's very, very useful. One of the ways that we can define queries specifically is to say, like, you want to say if the value is not this. Well, SQL Alchemy has done some nifty things to be able to use a tilde, which is, I forget which function that actually calls behind the scenes, to basically invert it. Invert the logic. I don't want it to be this Boolean, I want it to be not this, right? So that you can do all kinds of fancy things and make this easy. But let's take a look at this. Another thing to note is that there's not just something like dunder LT that you can use. There's also different ways of sorting. And the way that sorted works, if I was to, let's say, do this, comment it out, we can describe this sorting without having to, I'm going to run this, it's going to error, that's okay. We can also describe how to sort something by passing in a key. This key is a function. It takes a function, which takes an object and returns the value that we want to compare against, okay? So we could have implemented this with a lambda. Maybe I should have given an example of that just for completeness. But we can run this again, and now we're sorted by other. Something important. Attr getter is one of those things that's built into the standard library that not nearly enough people know about. Bill, like many times, is the one that introduced me to Attr getter. He uses them all the time in his code. And then I normally go, man, I always forget about that. That's such a nifty feature. Because what this is ultimately doing, and I'll just implement this in quickly for you. This is basically doing this. You know what a lambda is, lambda. And this is going to take an object, which is going to be our custom object. And it's basically just doing this. But that's a whole bunch to type out. Now, it's actually technically less than operator Attr getter. However, for larger things, it's sometimes not. And it can be very, very useful. And it's very descriptive about exactly what it's doing. Now, you can do all kinds of stuff within the lambda, and that's not necessarily relevant at this point. But operator Attr getter, there's also, what's the other one? It's Attr getter and, item getter, which works with dictionaries. So Attr getter works with objects to get an attribute off the object. Item getter works on dictionaries to get a key within the object. This is another way to do sorting. So you don't only have to sort with one object. Attr getter will actually return a tuple. And Python has implemented, and specifically in this case, it's going to be a tuple of integers because other and key are defined as ints. Right? I've defined them as ints. We can do a less than on a tuple. A tuple which has one integer and another integer. Python knows how to compare those things and spit out the right value. So if we run sorted on this, we get first 4798 on the key, a 2669 on the values here. And you see the key here is that other is sorted first. That's why we get 2669. And then key is sorted after that, which is why we get 4798. Note that up here it's that's actually really interesting. This is one, oh no, it's right. Okay. Whew. I was going to say, wow, non-determinism. 4798 right here. 47, it is right. Wait, hold on now. Here, see, this is, oh, I'm just dyslexic. 4978 and 4798. So you can see how order here did actually end up mattering. Okay, so this is a lesson in use the tools that are available to you. There's a whole bunch out there that you have available. You got to use them. And when you see scary things like LT is not, or less than is not defined, go look that up because it might actually be useful to implement under LT for you. Okay. Yeah, Dunder for almost all the Dunder methods, which is what these things are called. And it's because there's under is kind of an underscore is what this thing is, the character right here, right? And so there's two of them, Dunder, double, under. Anyway, it's shortened to Dunder. Most of the Dunder methods are supported in Python 2 and Python 3. I can't think of anything that isn't, unless it was something added in Python 3. For example, is there a Dunder async? There might be, but most of them, all the operators should be available to you in Python 2 and Python 3. Okay? Okay, let's talk about this one. This one is a really classic error. This is a classic error that I see a lot with very young Python programmers who don't fully understand. And when I say don't fully understand, don't for a minute think that I fully understand in the true sense of the word. The way that Python objects actually work. Underneath all of this stuff, there are objects within the system being created in memory. And the time in which that object is created, it's going to live for maybe the entire length of the application. So if you're building a web application or you're building a long-running CLI app that's like just kind of chilling out there and maybe exposing some sort of an API of some kind, or who knows what you're doing, right? If you create an object and that object never gets deleted, not because normally you don't have to worry about that kind of stuff, but sometimes it trips you up, like right here. There's two types of objects within Python: mutable objects and immutable objects. A dictionary happens to be a mutable object. It doesn't copy an entire dictionary whenever you add a key in. It doesn't copy the whole thing over and then insert your key and that's what it is. Certain languages do that. I can't think of any off the top of my head, but there are many applications. Haskell? Yeah, Haskell. Many functional languages. Actually, Elm does that. Many languages are like that, where there's no mutability. You can't change anything. Python, not so. We have dictionaries which are mutable. In here, we set it as a default argument on an object at a class level. That means that dictionary is not going to be created when the Python, let me rephrase that. When the Python interpreter hits that line, it's going to create that dictionary. Class instantiation time, if it's at the root level of a module, which is to say it's right where you see it here, it's not nested within a function, it's not within another class. There's a couple little bit of scoping things that we'd have to learn there, which we're not going to get into. It's at the root level of a module, is going to execute at import time. That means that that dictionary is created when the module is imported, not the first time you use it. There is such a big difference between that, because that means that dictionary and the ID, the memory location of that dictionary, is going to be created once and only once, which means every single time you create that object, you're going to be having the exact same reference to that dictionary. Dictionaries are mutable. As soon as you start messing with that dictionary, it's going to change across every single instance of your class. The same dictionary. Let me demonstrate. Okay. So we have something right here. We have a custom object, and we're going to run this one. This is the data of, Royce, there's something yellow blinking on my screen that says something about chatting.
It's just the chat.
Oh, okay. Well, I'm not in control. I just. Okay, so we see right here what I've run here: blank data ID. This is the. No, Roy, it's all good, man. It's all good. It's Royce's fault. No, that's fine. The you can see that the ID here is an integer. This is roughly equivalent to its location in memory. Okay, and we see that the data here is just an empty dictionary. No surprise there. Okay, let's create another object called other, and we're going to update that data and insert a key, A, and its value is going to be 1. Okay, nothing surprising there. We get back the other data. Now we see I kind of give it all away with this. That's really kind of a bummer. Then we print out blank.data, and we get A1. That is not intended. That is not 9 times out of 10, 100 times out of 100. You don't want that. That is almost never what you want. You never want an object created here and an object created here to share a value from there. This is the cause of so many random bugs. Because how do you trace that? This second object has to be created at some random point in the runtime in order for you to actually have this problem crop up. This is like one of those tracing nightmares. Make it even worse if you have, like, say, a uWSGI instance, and that uWSGI instance restarts every 5 minutes or something. Oh yeah, this is brutal. Because sometimes that uWSGI instance will execute and it will have that dictionary change, and then other times it won't, and you have no way of figuring it out. That's never happened to me. Yes?
What's uWSGI?
uWSGI is a C-based application to run web servers. I would love to tell you all about it after. Yeah, it's fantastic. I could tell you all. And then just to prove this point, let's just look at the memory locations of blank.data and other.data. They're identical. That's the thing that we need to note here. All right, the memory location of these two things is going to be the same. This is the correct way to implement that same thing, all right? The right way to do this is to assign the class level object to be none, which is not, none is created once. It's only created once. It's created when the interpreter starts. That's it, right? And then we're gonna assign it here. And then within the init method, which is the method that runs when you have a completed object. This is your hook into augmenting the object's state as soon as it's created. Okay, there's actually another method previous to this called dunderNew, which is how it actually gets created, but let's not get into that right now. The right way to do this is to assign that dict to self.data. And if we look now, these two objects, if we look at them, are different. Right? They're at different locations in memory. Right? This is the right way to do any sort of instantiation of mutable data at a class level. You have to do it this way, otherwise you'll get yourself into a world of hurt. Okay? Any questions? 1 second, Bill. Yeah. This? Yeah, the trick here is assigning this to none, right? If you assign it to none, that means whenever the object is, let me demonstrate this. Yeah. I don't have Vim. Ugh, bummer. On the class itself, there's actually a thing called data. And that's really what's going on underneath the hood here, is that the class actually has a dict underneath it, which is underpinning all of these values. And that dict is being populated when the interpreter hits that line, opposed to when it's actually being executed, which are really two different locations in memory, or in the actual Python interpretation. I don't know if that actually helps. Does it? Okay. Yeah.
I was going to ask, does the same thing happen when you, if you would have defined a parameter and you default the parameter to a dictionary? There's a whole reference there too.
What do you mean default the?
Say that in that Dunder init, one of the arguments in that Dunder init took was call data, and you set data equal to dictionary.
You know, I thought I had an example of this applicable to functions. It's a really great point. Thank you. This is also wrong. What, Brian, do you mind if I just, yeah, okay, great. So this is also wrong. And this is not at the class level, but at the function level, which actually might be where you run into this more often than not. So let's say we have something like incorrect function. And that takes a data, and you want it to default to a dict. This is also very wrong. Because what this also does is at importation time, not at execution time, that dictionary is created. And now you have, if you do any sort of mutability in here, let's say you say data A takes the value of 1, and let's just print out data here. Note that I'm printing out data before any assignments, okay? And then we're going to call incorrect function. We're not going to pass in anything that time. And then, I can edit text. And then we'll do it one more time, but we'll pass in data equals B2. Okay, if we execute this, is that right, guys? Yeah, okay. Note what happens. The first time we get the right result, empty. The second time we get A1. And that's because this right here is changing a mutable global object, effectively a mutable global object. And that global object sticks around until you delete it. And that delete is not going to happen for you automatically like it normally would in Python. Normally, when something exits scope, Python interpreter ditches it, gets rid of it at the next garbage collection. This time, not so much, because it's global. Until the program executes, it's going to keep on going. And you'll see we kind of get the right result the second time because we're actually handing it in. We're not using the default value, we're using the passed in value. Okay? Any other questions? Thanks for pointing that out, both of you. Anything else?
So things
the right way to do this is likely the same way. This is how I normally do it. I would do this. I like this method. If data is none, else data. Oops, I'm not in Vim. That's how I would do it. Most of the time, that's how I do it. And I like it because it's in one line and it's an assignment. And it's really an if based on an assignment, which actually gets much easier later in newer versions of Python, not unreleased versions of Python. This will become a little easier. Yes?
You also do data or?
Oh yeah, that's actually another, yeah, that's actually probably the way I would have done it. You're right. Yeah, another way to do this is this. That's actually shorter. That's, if you look at my code, that's actually probably what I do. Yeah, that actually, Elliot, that's a great point, Elliot. That doesn't work for false. If you want to pass false to data, that actually doesn't work. And this is probably the right way. Anybody else want to throw in any other piece of information that could tell us why this is wrong? Yeah, that's such a great point. None is actually a very difficult thing to overcome if you just do if. You have to check explicitly for none. None is the right way to check for none. Thanks, Elliot. Okay. Okay, let's see if I can actually get this thing onto the screen. I warn you, this is mostly a trick, but I want to see. Can you still see that? I know it's small, but I need to show you all of it. I will note that I'm importing random at the top, but that's not really all that relevant. The rest of this code is. This is what I want you to do. Find the error. What is the error that if I was to catch this would be caught? What would E be? And if you're one of the 3 people I tested this on, please don't answer. What's the first error? Or if you have 30 years of Python experience or something and like a core dev. I'm really sorry. How about this? You know that there's a try except block there. I'll blow it up. Just know that there's a try except right there. That is a fantastic guess. Unfortunately, it's incorrect. Nope, it is not line 8, if that's what you're saying. Can you point to the place of the, do you know the line number? Oh yeah, that's fine. That technically is legal, but it should be that. Thank you. That was just a typo. That variable, that can actually be named whatever you want. Self is the idiomatic way, and in this case, CLS is actually the idiomatic way. What's the first one?
Where you have BC equals that calculator. There'll be a new instance of it.
What's the line number that the exception will be thrown? No. You're on the right track, though.
29. You've got a class. It is not a state sheet.
Yes, very good. Yes, this is actually going to throw a type error. Actually, yeah, a type error. Yep. Okay, ready? Ready for this? Oh, it's tragic. If I just execute this, it executes fine. But then if I comment out the pass and I throw in arrays, bwah, bwah, bwah. That's not right. That's really funny. I changed this like 4 times. Where are we here?
You put a percent sign on 23 for the operator. And have
Yeah.
to put that one first.
That actually in this case is not the problem. At least I don't think so.
You
Top
did
process.
random shuffle of your array and put the percent one first, so it fell through.
Oh, you're absolutely right. Well done. Yeah, no, that's great. That's a great example. Thanks. I appreciate that. If I do that, thank you. I appreciate that. See this? That's exactly what happened. The random.shuffle got added like 3 steps later. Thanks. You're absolutely right. Sorry for discrediting you right away. I apologize. Yeah, see how this throws a type error? That is so annoying. You want to know why it's annoying? Because there's like 4 different places that it could have thrown an exception. And the one thing that it caught was something that none of us would have ever guessed right away. Like we see 3 exceptions on the screen and we're like, it's probably going to be one of those. There's some pretty obvious ways that it could be that. Right? And in fact, there was one even on the screen that I wasn't even expecting. Like that's a great example right there. Code like this is incredibly hard to debug. And the reason why it's incredibly hard to debug is because exception as E is almost never what you want, as well as its variant, which is just except, which will catch one extra thing, base exception.
Might be worse.
Which might even be worse. That's like the sure sign of, again, professional programmer, common mistakes. Other sign of laziness. Like now there are situations 1 out of the 1 million times that you should ever do this, right? And there is 1 million times, and we ran into it about a week ago. I ran into this with some code that Randy had written for some processes that were like 4 layers deep in dependencies. And this person raised an exception at the very bottom, like of our traceback. It's like we have no other option but to catch exception, which is awful because if you have a syntax error, you catch exception. Well, maybe not syntax error, but you'll catch exception for almost everything. So now, let me ask you this.
I'm sorry. Someone do.
Yeah, no.
Exception is the base class exception. You're saying you should throw something more specific.
Yes, yeah. Because ready, here's the next point. How do you solve the type error? Pretty straightforward. Randy?
Before we move on, I would just like to make 2 quick points that kind of go back to things that you want to do as a software developer. The first one is, and I see this all the time when we do home screens, if people do like demo coding, which we don't do a lot of, but we do a little bit. They get errors and they don't read the error.
Yeah.
They assume they know where the problem is. so many problems can be solved sooner if you actually take the time to read your stack trace and make sure that what you think is the problem aligns with what the stack trace is telling you.
Yep.
So that would be the first thing. And then the second thing would be, I have found myself in situations where I have to catch a fair accept. One of the things that I've learned to do is when you catch that E, you can turn that into a string, and you can do string matching on it.
Hold on, we'll get there. So we're going to get there. Thanks. Okay, so fix the exception. How do we fix this? What's the, anybody just shout out? Anybody? Huh? Yeah, add some parens, right? Instantiate the bad calculator. The issue here is that we're calling an instance method, which expects, an instance, and we're calling it currently as a class method. That's illegal, right? So what ends up happening is self gets populated here with A, and the A gets populated with B, and we have nothing here for B. That's the problem. That's what the stack trace says. Bad sub missing one required positional argument, B. It's saying, you've given me self, you've given me A, why didn't you give me a B? I need a B, okay? That's kind of a cryptic message in the first place, but nonetheless, we instantiate it. This will run, what's the next exception? What's the next exception? Which is the correct answer? You have no idea what the next exception is. And worse, what are you going to do about it? I kind of gave my hand there with the worst word. Yeah, you have actually, in this scenario, I've kind of set up an implicitly bad or explicitly bad scenario. You can't solve this problem. You have absolutely no idea which exception is about to be raised, and you have no way of doing it, even with string matching. Why?
The same exception message.
They have the exact same exception message. Look at this. If I get an A that equals 0, I'm going to get an A can't be 0. If it ends up hitting this one first, because the random.shuffle gave me that one, I'm going to get a B can't be 0. You can't string match on a variable. There's no way to do it. So the lesson here, the overarching lesson, and there's absolutely ways in which you could catch this operation not supported. That's an option. But for certain types of exceptions, you can't even do it with string matching. The only real way to do this would have to be to import trace back and figure out where in the stack this came from, which is like the antithesis of programming. That's like punching walls. That's awful. That's terrible. Don't do that. All right. So what I'm trying to articulate here is you have to be really careful about what exceptions you raise, when you raise them, and what you plan to do with those exceptions. When you're inside your actual application, the code that you're actively working on, it might be okay in certain circumstances to not create custom exceptions and all that kind of stuff. If you're ever developing a library that you intend on using across projects, you should almost never raise a base exception, like either an exception itself, a value error, a type error, anything error. Inherit from the base. If you're expecting a particular parameter to be within some acceptable range and it's not within that range, subclass value error and raise your custom exception. That way, some poor programmer way at the top of the stack can say, I don't care whether or not I pass in the right thing. I want my program to keep on executing. I don't care about errors in your library. Your library is meaningless to me. You just do what I tell you, and then you don't do what I tell you, and I want to be able to pass it. I just want to be able to move right on, or handle it in some safe way that I want to deem. So if you're writing library code, this is really important, that you mind your exceptions, what you're raising up, because who knows, some poor guy sitting in his office is going to be banging his head against the wall because there's no way to catch your exception. And that can be really difficult. And worse, it's really bad when you're the one that wrote that exception and you have to catch it yourself and you're like, man, I should have wrote my own custom one. Okay? Any questions on this? Comments, concerns? Tell me I'm stupid. Yeah.
When I was working in, there was an error in the calculations, you couldn't find it. I might have to check it behind you. You would say ESP, error someplace.
Yeah. Yes, sadly that happens. Okay, two more things quick. This is a none returns. What is data is here? So we're taking data, we're assigning it to AA1, we're updating A to B2. What do you expect line 5 to print out?
Can you expand your font?
Oh, yes, I'm sorry. What do you expect line 5 to print out?
You're adding a string.
Really what I'm asking is, what is the value of data going to be on line 4? This is just fancy string formatting that don't worry about all that much. Data is what? What is data going to be? Okay, it's one option. Anybody else?
Isn't this an exception? Doesn't update take a issue?
No. Yes, Elliot is correct. This will print out none. What is adder going to print out on line 11? Let me rephrase differently. What's the implicit return type of a function? None. If we had to execute this, data is none, adder12 is none. When you forget to put your return types in, or when you forget that certain methods on certain functions actually return none, they don't return the updated object, you're going to have a bad time. It would save so much effort if you could just not have to do this. But unfortunately, the correct way to do this is that. The correct way to do this is that. And now we get the expected result. Okay? One last thing here. Minding your commas. Where's the error in this? Oh, buckets. Crap.
Jerry thinks so.
Yeah. Everybody close your eyes. Where's the error in this? Where's the error?
C is going to be a set.
C is not going to be a set. -5 points for Brian. C is going to be a tuple. C is going to be a tuple. If you look at what mything.c is, you find that it's actually a tuple. Tuples have nothing to do with parentheses. Tuples have everything to do with commas. And when you're constructing declarative objects, especially things like most common to me are SQL Alchemy, what the forms, if you're using any sort of, I don't know, what's another popular, because I don't think pandas have anything to do with declarative stuff. I don't know. Anyway, the point is, at instantiation time, this thing's created not as a declarative attribute, but rather as a tuple, which really has a whole bunch of problems if you're trying to override dunder new, which is kind of a more advanced topic, but we won't get into right now. So when you got to be really careful to make sure that you don't leave stray commas around. Commas can cause a world of hurt. Hours of debugging have been caused by stray commas. That is all I have. Common, very everyday problems that professional software developers make. Some of them are arrogance, like what you saw demonstrated with, no, it's not, doesn't have anything to do with the shuffle. That's silly, except it had everything to do with the shuffle. Some of them are simple as just commas. Stupid little commas, which is why we should have semicolons at the end of the line. Sorry, that's probably an inside joke. Oh, yeah, sure. Yeah, sure. I could probably, that would have been helpful. A great way to do this one would have been class. Let's say you just want to catch generic calculator exceptions. A good way to do this would be call it a calculator error. In our case, the right thing to probably subclass from here is value error, not just exception. That's all you have to do. Now you can do far more fancy stuff, like you can define init on these and say self the value, and maybe even put in like an op here, like operation. And you could say self.op takes the value of op, and self.value takes the value, and delete your thing here. And instead of this, you could raise a calculator error and pass in the add and maybe the A. And it's a terrible place to put that. And then, you know, you could do the same thing here for your bad sub. And then here, right here, the right thing to do here is not necessarily to create your own, but probably to raise a not implemented. That's probably the right thing to do. And now, within your code, you can accept a calculator error. Maybe we only raise on those. Oh, thanks. I should have just done that. Watch me type because that's atrocious. 0 can't be 0, which is this exception, right? Now we can accept that one too, right? If we want to catch that one. Because we don't care about your silly exceptions. And now we're catching the calculator error. Maybe we don't want to catch that one either. Now we can do this a whole bunch of times until we hit our not implemented error, which might never happen because it's random.shuffle.
Well, you got the general exception, right?
Oh yeah, you're right. So if you really wanted to do something like that, you could do. What long lines with no spaces?
He's talking about 45. Yeah, 44 and 24.
Oh, this complicated file loader adder thing from network request class that you don't control? That thing?
Yeah.
Oh, that was to simulate that this is from somewhere else. Like you don't have any control over this thing. It's just, you're just calling it. And I thought that I would be funny and say complicated file loader adder thing from network request class that you don't control. Because saying that is kind of fun. Complicated file loader adder. Yeah, it's definitely a simulation of Java errors. Any other questions, comments, concerns? Tell me I'm wrong. Yeah, pass is a great way to basically say, I don't want you to do anything. It's a quick way of, pass is a statement. So it's an actual, you can use it anywhere. There's a couple different types of things in Python, like a statement, an assignment, an expression. Pass in this case is a statement. You can use that wherever a statement needs to be, like within a lambda or within an exception like this. And it basically says, go on to the next, whatever the next execution is supposed to be, past this line.
Why did we need it?
That's just kind of an idiomatic way to say I don't have it there anymore. But you're right in saying that I had.
That's not bad.
You have to put a line in the body of the class, otherwise it won't have the class over. So where you basically don't want to do anything, you want to do no operation, you can use the pass just to show that the significant white space that you're going to do.
I actually think that used to work in Python too, but I don't remember. Is it a doc string? Yeah, there is another way of doing this, which is.
Should we name don't ever do this?
No, it's fine. I mean, it's another way to say pass. Depends on how lazy you want to be. Pass is an option. You have to have some statement within the body of the class. Other questions? Yeah, don't do this. Other things. Anything else? Thank you very much.